Good afternoon and welcome to the 29th annual exhibit of hydrogen fuel cell technology at the Hanover Fair. We have a special event today, and it's a little bit unusual, although we've been doing this for years. In fact, it all started, I think, about 7 years ago with maybe 5 participants. These participants produce the electrolysis units that produce green hydrogen, as long as you use renewable energy, of course. And this is fundamental to implementing any zero emissions economy. We need electrolysis because if you have renewable energy, you really need to store it. You also may need to export it because who believes really that there's enough renewable energy in Germany to decarbonize the industry, to produce cars that don't use combustible fuels, and also to provide electrical current? It's not going to happen unless we import hydrogen, and hydrogen needs to be produced. Hydrogen is only an energy carrier, so we need these people who provide the magic of separating the water molecule, delivering pure hydrogen, and allowing us to recoup that energy. It's also the only way you can store energy. If you look at Germany, right now we're turning off wind turbines because there's no place to go with the energy. This is fundamental. If we cannot store renewable energy, we can't harvest more of it, and we're dragging our heels. What have we learned? Have you seen your energy bills increasing? Why is that? Because this is also energy security. What about knowing you have a diversified supply chain? What about being able to consume renewable energy that is produced all over the world in areas where there's a lot of solar power? So this is among the issues we're facing. There's a pile of other things like decarbonizing the industry. This may involve something quite local. It may involve supplying energy to remote communities in Africa. But it is a path we are on, and it's obvious where we're going. The only question is, will we get there in time? Ladies and gentlemen, will we get there? I have today 9 participants who are all experts in the field of electrolysis. And these people are going to talk about their individual products. Of course, the presentations, the elevator pitches are rather amusing. You have an elevator door, it opens up, you got to start talking quickly. You have 3 minutes to state your case. If you go too long, at 5 minutes, we have a nasty lady with an umbrella who chases you off the stage, and the next person comes up. You'll see their names on the board here. After we finish the presentations, which hopefully doesn't take too long, 9 guests, 3 minutes apiece, we'll start the conversation and we'll open up the conversation to the audience. And this is where things get really interesting because these people are brutally honest about where we are. Did you know that 1% of the hydrogen currently consumed in the market is produced through renewable energy? The rest, it's nasty. And that has to change, and these people, that is their fundamental interest. So I'm going to start with no prioritizing, of course, simply one company after the other. The first up on stage is Manuel Anselmo, who's an R&D Project Manager at BluEnergy Revolution. Please welcome with me, Manuel Anselmo.
How about the mic? Hi, everybody. Can you hear me? Wonderful. It's a pleasure to present you today our MOSE, Modular Smart Electrolyzer, and to represent our company, which is BluEnergy Revolution. We are from Italy, we are from Genova, and we are system integrators. We are experts in hydrogen technologies, and we want our experience to shine in our product. We are newcomers, so today at this fair, we introduce you to our product, the MOSE. So let's see. So here you see our system. This is a very compact electrolyzer. It is a PEM electrolyzer, 40 bar of hydrogen pressure, slightly less than 0.3 kilograms per hour of production, and of course, pure hydrogen, 5.0, 99.999% purity. So it comes out of our experience as system integrators. So we dealt with projects in the hydrogen generation. We gathered that experience and we came out with a product. Along with our MOSE, we have our Blue Demi, which is a demineralization unit. It serves to feed the electrolyzer with demi water. To make hydrogen, you need water. You split water and you make hydrogen. Here is the concept of modularity. Mo stands for modular, okay? So you can couple our electrolyzers, one next to each other, combine gas flows, combine hydrogen delivery, and have one bigger electrolyzer. So the range is from 15 to 75 kilowatt, from 3 to 15 normal cubic meters per hour of hydrogen production. If you want to go bigger, then this product is not for you. We target a specific size, this small size, for many applications, from industrial to residential ones. And here you see how they couple to each other. So you will have one single hydrogen delivery, you will have vent from the electrolyzers, and our products are thought to be maintenance friendly, easy to integrate, easy to connect, and simple to maintain. Flexible control, DS, stays for smart. So we control it by web app, and we can control the system by remote, fully by remote, and gather the data. So here you see we collect all the data, and we provide the customer a predictive maintenance. That's our idea, to serve our customers with our experience in hydrogen technologies. We shine with components, so our experience is in the selection of components, not in the design of the technology. We are not the manufacturers of the stack. What we put is a custom product, competitive, and very compact and safe. So here you can see some of the names of the industrial partners who supported us with high quality of components. We are newcomers. How can we prove you that our product is a good product with high quality components? Please visit us at stand D37, just right there, to view with your own eyes our product. And please let me thank our partners to support us in this fair at Hannover Messe. So it was a pleasure to present you with our Mose. I hope you will want to visit and know more about it. And of course, I'm looking forward for the discussion, which will be later on in some minutes with the other players of the pitch. Thank you, everybody, for your attention, and see you next time. Bye-bye.
So thank you, Manuel. Next up on stage, and by the way, I think a microphone is being delivered here. We want the optimal tone quality there. Next up on stage is James Zhou, who is head of the digital department at Hydo Tech. Yeah, please welcome, microphone, please welcome with me, James Zhou.
Okay, hello, good afternoon, everyone. I'm really happy today here to introduce and share all of you with our newest technology and our newest product. I'm James Zhou from Hydo Tech. We are a company based in China, but we are already a global company. So in the wave of the decarbonization, we see that the green hydrogen is really a new solution to our mankind. So this is also our company's vision, is to empower the green future by leveraging our product and our solution in the green hydrogen. So now our manufacturing and our main office is based in China, but we also have set our footprint to the global. So the first step is in Germany. Yeah. So what we do, our product is focused on the green hydrogen industry. So first is our alkaline electrolyzer. You can see here, this is a brand new version. We have already several in operation. Not only the standalone projects, but also we can do that in the hydrogen producing and the filling station. To add in some more intelligence flavor to our product, we also have the HYDOsphere, which is the digital management platform for our product, so that you can basically manage all the devices and also the equipment from anywhere in your office and in your plant. So we have done that for standalone equipment, but also for a very big hydrogen plant in China. And also, we are doing the Hydo Tech, which is our hydrogen safety solution. We know that safety is always comes first to such a big project and in the energy level. So our original technology was from the Winter Olympic Games. You know that the Olympic was purely driven by the hydrogen. So we provided the safety solution to ensure that the hydrogen torch is safety during the whole Olympic game last year. After the Olympic Games, we upgraded our solution, and now it's already used in several of the national laboratories to ensure that during the whole process, the hydrogen is safely used. Yeah. So to go more deeper to our key product, the hydrolyzer, which is the next level, we say that is the next generation of the alkaline electrolyzer. We have optimized that in 3 aspects. First is the cell level. We have done that in a standardized shape. And the second one, stack level, it is pressurized. And also in the system level, we make it smart and safe. So what does that mean? By standardized the cell, you can see this is a real picture from one of our projects. It's totally different from the other product, which is round shape. We do it in a rectangle shape, and we redesigned each of the cell and optimized it into the upper limit of their efficiency, of their safety, and also their intelligence, so that it will be very easily to scale up because they are all the same. So not only for containers, but also for without container or even a plant level, we can easily scale up with exactly the same cells. This is the cell level. To make it standardized, it will be very cost effective when we are going to massive production. This is how we see the cells level. And in the stack level, we see the alkaline electrolyzer can be categorized in 2 dimensions. The first is whether it's standardized or customized. This I already discussed about. The other dimension is we see whether it's pressurized. Why do we want to do the pressurized one? It is because the pressurized will be more benefit for the downstream applications. What we see is that we are basically the only one doing a standardized and pressurized alkaline electrolyzers now. It is already used in several downstream applications. For example, what I mentioned, distributed and energy system, it's already in operation. And also in transportation systems, the fuel cell vehicle, they need very high pressure hydrogens. So our pressurized electrolyzer, their output is already could save 1 or 2 compressors for our end customers. And also it is very user-friendly to the chemical industry. As we know, the chemical industry, they have massive plans to consume tons of hydrogens a day. And our product, our solution, will provide around pressurized hydrogen that can directly used for them to produce ammonia. Yeah, so this is already in build and will be in operation by next year. And last but not least, the system. So safe and smart, I will not discuss more about that. Basically, we have added the intelligent sensor and also our digital management and also the advanced algorithm to ensure our system is able to better fit for the green electricity, the renewable electricity, regardless of their unsteadiness during the operation. Yeah. So that's all about our product. About our company, we already are very ready to launch to the global market from the certification level, from our manufacturing capacity, and also all the key technologies I mentioned. We are fully owned of our own intellectual properties. Yeah. So it's a very short time today, but I really want to invite all of you to our stand. It's in B29, just several steps on that direction. So very happy to meet you and discuss in details about our company. Thank you.
Thank you. Thank you. Up next on stage, of course, already here, is Denis Thomas, Global Business Development Leader at Accelera by Cummins. Denis.
Great. Thank you. It's a pleasure to meet you all. I see a big crowd. If I exceed the 3 minutes, please wave your hands. So I'm presenting today Accelera by Cummins. It might be a new name for you, but actually we are not new in the field of electrolyzers. We are Cummins, and as Cummins, we are developing engines, power generators, which are based on diesel and also gas. But we started to invest massively into hydrogen technologies and zero-emission technologies. And all those technologies, they are to be found under the brand Accelera by Cummins. We employ more than 60,000 people in more than 190 countries. So when you hear Accelera, understand that it is in fact Cummins. In terms of electrolyzer offering, we are in that space for more than 70 years through the acquisition of Hydogenics, which was done in 2019. And here is our current product offering. So we have a mix of products between alkaline and PEM technology. We use alkaline mainly for the small-scale type of systems, so containerized solutions with all the balance of plant directly attached to the product. So that's a plug-and-play type of system. And then when we start here, above like 2 megawatts, we are offering a containerized PEM system, which is based on a cell stack of 1.25 megawatts of input power. And so the system that we can offer, it's up to 2.5 megawatts in two 40-foot containers, one container for the process and one container for the power. When we exceed 15 megawatts, we are offering a different type of product, which is not containerized. That's an indoor product that needs to be integrated by EPC companies, integrators, etc. And so in that case, we have developed the Electrolyzer 1000, for which we have already a unit in operation for more than 2 years in Canada at the site of Air Liquide, where the hydrogen is being liquefied for industrial customers. And there we use a stack of 2.5 megawatts. We are releasing this year the Electrolyzer 5000, which is a 25 megawatt building block, again using this 2.5 megawatt cell stack. We have secured a first project in Canada in the size of 90 megawatts with that project, which will be delivered in 2025. And then we are also developing, let's say, additional solutions for the very large scale type of projects, but we are really currently focusing in that size of projects right now. So in short, what are the key messages that I wanted to convey to you today is that we are Accelera by Cummins, so please get used to this name, it's important, and there will be a lot of announcements in the coming weeks and months. 70 years of experience in electrolyzers, a clear focus right now on PEM, but we like also all the other technologies. We operate currently the largest PEM electrolyzer in the world for more than 2 years, and we're continuing our expansion. And also in terms of manufacturing, we're expanding in different geographies, in the Americas, in Europe, in China, and we expect to have a production capacity in the range of 2 to 3 gigawatts in the course of next year. And we had the pleasure to host President Biden in one of our factories in the US 2 weeks ago, and I hope my presentation was interesting for you. Thank you very much.
Thank you. Perfect. Up next on the stage is Yong, who's Vice President of Sales at Green Power. Welcome, Yong.
Thank you. Guten Tag. Good afternoon, ladies and gentlemen. I'm Yong from Green Power, a manufacturer of electrolyzers and a system integrator of green hydrogen production. I'm so excited to be here today because we have been here since 2019, but today we finally made it. Today we are here to talk about green hydrogen, and when we talk about the future of green hydrogen, we have to consider the cost of producing green hydrogen with other hydrogen, black, green, or blue, etc. So every penny counts. People are concerned about the cost of electrolyzers, of course. But if we look at this picture, if we look at the whole process, we should not ignore the efficiency of power supply, which directly determine how much power generated will be used to produce hydrogen. Just for your example, if you are running 1,000 cubic meter per hour or 5 megawatt electrolyzer, just 1% reduction in the efficiency of the power supply unit will cost you an actual 24,000 euro each year. That's a brand new Audi Q2 SUV. What if you are running a 50 megawatt plant? That's a lot of money. Depending on the source of electricity, different kinds of power supply units are used. Typically, the solar power and the wind power will be transmitted through the grid, which is also the simplest scenario. AC/DC rectifier can handle the job. And nowadays, the end user prefers to connect the solar and the electrolyzer directly, or the wind and electrolyzer directly. So a DC-DC converter or AC/DC without the transformer will be used. And under a more complex scenario, when using multiple energy, such as combining the solar and the grid, or even solar, wind, and the grid, an integrated power system will be used. In addition to different types of power supply units, there are a lot of other parameters which will affect the total cost of power supply unit, such as the efficiency, power factor, total harmonic distortion, current ripple, etc. And in most cases, the end user has a very limited space for the PSU. So the size matters. Well, it's very difficult to complete optimization of the power supply system in 3 minutes. So welcome to our stand. We can have an in-depth discussion there. That's E39. Thank you. I'm Yong from Green Power.
Thank you. So up next on stage, which direction am I looking in, is Haibin Zhou, who's the general manager of Suzhou Green Hydrogen Energy. Where are we? There we are. Hello. Haibin.
Good afternoon, ladies and gentlemen. Really excited to be here. After a long time, since 2020, we were supposed to be here. You can imagine how difficult it is. We make the way to Europe after this COVID control in China. Since we are a company based in China, I would like to give you a quick glance about the economy of hydrogen in China. The government has launched the plan of 2030 for carbon peaking, and also 2060 for the carbon neutralization, which means that we have 90 million metric tons of green hydrogen requirement by end of 2060. And these are the prospects of the green hydrogen, that we have more than 100 plants in China related to the green hydrogen ongoing or be planted, and expect to be reach 1 million metric ton of green hydrogen requirements by year of 2025, and over 15 gigawatts electrolyzers to be delivered from 2023 to 2025. Of course, these green hydrogen generated will be applied in various applications like the industrial, blending with natural gas, mobility, and most important, that as a element of energy storage with related to the renewable power. So who we are? We are a manufacturer and a total solution provider specialized in green hydrogen. And we, not only in the hydrogen industry, we're also capable to provide our green nitrogen solution to collaborate with the green hydrogen for the green ammonia generating. And we have our business sales footprint across the world, and we hope to have our first joint developed stack installed in Germany soon in this August. So we are capable to provide the different solutions for the hydrogen generating, including alkaline, PEM, SOEC, and AEM. Of course, currently we have our alkaline and PEM on stream, and I hope our team will work on the SOEC and AEM will come in a very short time. So we are specialized in the alkaline electrolyzer with the range from, let's say, 2.5 kilowatt to 5 megawatt single stack with the latest technology by the added value for the customers by amps the high efficiency and the low power consumption, and with the module and the compact design for the balance of the plant. And more important is that we have our in-house fabrication for the 4 lines of the bipolars that can ensure that our in-time delivery of the system for our customers. And of course, for PEM electrolyzers, our team has made a great job that have the new type ordered error MEA, which can increase the electrolysis efficiency as well as the lifetime of the stack, and unique micro hole diffusion layer, which will have less requirement of the CCM. The PVD catalyst spotting technology will precisely control the catalyst usage and dramatically save the amount of the catalyst, which is a very key element of the cost. And of course, the patent bipolar pass design will make sure that the fabrication will be easy and under very low cost. So these graphics give you more details about the comparisons of the cone array arranged of this stack. In a word that we are a solution and manufacturer for the green power to X. And so we have our existing plants delivered around the world, and we have the references in Europe, in Netherlands, in Bulgaria, and in Italy soon. We will have our R&D center in Italy in a very short time. So welcome to visit our stand at F19, and we are very pleasant to have more discussion with you. Thank you very much.
Thank you, Haibin. So up next on stage is Ulf Jörgensen, who is CEO at H2 Core Systems. Welcome, Ulf.
Thank you, Brian. Hello, everybody. My name is Ulf from H2 Core Systems, and I'd like to introduce H2 Core Systems and our products and whatever we do to you. First of all, a small glance about our product line. About our products, we see ourselves as integrator, as starting at the electrolyzers, but in combination with fuel cells, storage applications, compression, and even dispensing systems or whatever. We can deliver and set up global projects for complete energy solutions, hydrogen-based. And as you can see, we are starting very, very small, starting at 2.4 kilowatts and going up to megawatt scale, completely modular and scalable for every size, whatever is needed. There should be more slides, so there it is. Okay, that's another picture of the same products. The main topic we want to achieve, the main goal we want to achieve is speeding up energy transition. This is our heartfelt goal, and we are completely convinced that we can only do it by teaming up with partners globally. That's why we, as a relatively small startup, we started 2.5 years ago, we already achieved to realize more than 200 hydrocarbs projects in more than 40 countries all over the world, teaming up with global partnerships. So, and it's very slow, but it's hopefully working. Next slide should be coming in a few seconds. There it is. So global partners is what we are working with. So as you can see, one of the major partners is Enapter and Intelligent Energy. Enapter for the electrolyzer part and Intelligent Energy for the fuel cell part, but also teaming up with global partnerships for complete energy solutions, starting at the electrolyzer part and combining, realizing projects, for example, for grid stabilization, for mobile phone antenna systems, energy backup solutions, and whatever is needed. because only with those partners we can realize global projects in a very quick manner, because we see ourselves as a workshop for our global engineering partners or our local partners who take care of the customer needs, and we produce in series the systems they need for their projects. And in this possibility, and this way of working, we see a huge advantage to speed up energy transition, because everybody can concentrate on his own priorities and whatever he can do, and doesn't need to build up a whole complete production process on his own. But his knowledge about the local markets is needed, and that's what we can deliver. So quick is teaming up with partners, and that's what we want to invite you to experience. If you've got any questions or see yourself as a possible partner, please feel free to join us in booth D10 in this hall, and thank you very much for your attention.
Thank you, Ulf. Up next on stage is Ole Jensen, who's Sales and Business Development Director, Northern Europe at NEL Hydrogen. Welcome.
Thank you. It was working. Thank you very much. We have to go a little bit back in time. Everything started in 1928, 300 megawatt water electrolyzers in Norway.
Microphone.
So we have actually quite good experience in it. But today, I'm not going to talk so much about the alkaline. I want to promote the elevator pitch on the PEM technology. Just to give you a short overview on the alkaline, we have roughly 500 megawatt capacity factory today. Next year, we have 1 gigawatt. So there's plenty of electrolyzers to all the projects. Just to talk a little bit about when is a product ready for the market. And one of the things, we hit TIL9 in 1985 with the stack you are seeing today. So it's the most proven stack that is available on the market. It's the most safest one. So, there we go. Yeah. So what it is you're seeing here, this is our PEM electrolyzers. Normally NEL, we are talking about alkaline gigawatt projects. But the PEM electrolyzer is also changing now. It's getting more efficient, it's very reliable, and it's also very competitive. So these, oops, not touching. So where we are with the development for the TL9 for the PEM electrolyzer, that is 2019. But what it is, this is not the most important. This is the journey. How do we actually come to this figure? How are we ready for this technology? And how can we secure your investment? And I just want to open up a little bit about the journey. When we are testing things, the stack and the membrane we are using today, we start testing that in 2003 with real tests. And we found out the stack was not performing good. So we developed a new stack, tested that in 2005, and 40,000 hours real test, we concluded 0 degradation. Degradation is not somebody people want to talk so much about, but we are very proud of this result. And we have also collected a lot of hours. The question we always get, alkaline is better. It's more reliable and it has a long lifetime. But today, the PEM electrolyzer can actually run up to 85,000 hours. And we have an electrolyzer in the market that have reached it at 30 bar. And with minimum degradation. How do we scale it up? Because this is proven technology, and now we want to go into the 100 megawatt projects. So we signed an agreement with GM to reduce our price and increase the quality further. And the result of that, that is now we are in the map. everybody is talking about the $2 per kilo of hydrogen, and we are actually there. So what it is I have tried to do, that is to make a matrix where we have the energy price from wind farms, PV, hydro, and then we have your capital investment. So we are very proud to say the PEM technology is belonging in the 100 megawatts, and we are below the $2 per kilo. The most important thing is that safety and reliability. Because if you don't prioritize these two things, you don't have a good project. So safety and reliability, then efficient, and then the price, not the other way around. So both the technologies are proven, and they have their benefits in the green hydrogen. So that was everything from NEL, and thank you very much. And if you want to hear more, just come over to the Norwegian corner, and we are happy to support you.
Thank you, Ole. Up next on stage is Mario Dragoni, who's CTO of HYDEP. Welcome, Mario.
Do you hear me? Yeah. I'm Mario Dragoni. I'm a CTO of HYDEP. And HYDEP is a company we founded more or less 24 years back. And we are specialized in design of a BOP, design stack, and design also the plant. So now we are looking to improve our experience in new project. For the target is to reducing the cost. Our approach is a little bit different than the market. We are looking to reducing the cost by integrating system module. This is a new approach, and we are waiting the patent in coming months. And the next is alkaline water electrolyzer, high temperature and pressure. This is two ways to save money. So the cost, in general speaking, the cost for the production is more or less 70% in power, 20% in CapEx, in OpEx, and in CapEx and 10 in OpEx. In this way. And our proposal is to reducing the cost in CapEx, integrating in the stack many functions we have around the stack. For example, all the separator and sensor like this starter dart. This is what we want to do, eliminate the separator, eliminating the water level, refilling, a pressure switch, pressure transmitter, safety valves, and temperature transmitter. So this is the result. You can see in our bot the prototype. We are maintaining the external pumps and then the heat exchanger. The reason is very simple to understand. If we have natural circulation inside, we have to wait a few hours in order to be operating. Using the pumps and heat exchanger, we can be very fast. In our simulation, the result was 10 minutes to reach the operating condition. Okay? So the advantage is we save, at the moment, more or less 10% of VAP cost because we don't need a separator. Of course, we need to maintain the sensor to manage everything. And we go fast because we don't have a long time, okay? But we have internally separator, what we say, safety valve, and the construction, the footprint are very reduced, and we can save also space, and it's a cost. Cost reduction per stack The second point is energy. The energy is very important because it's the main cost. We showed before 70% of the cost of hydrogen production is energy, power. So what our approach is to use the temperature to reducing the cost. And for this reason, we have a project, alkaline water electrolyzer, high temperature and pressure. It's not SOEC. It's completely different. We are not using the steam directly flow in contact with the ceramic electrode, but we are using only the steam to warm the KOH, the solution KOH, and we need the pressure to maintain liquid KOH. So this is a very important for us approach, and we can show the advantage. This is a curve where we show the efficiency of the electrolyzer increase because we're reducing the voltage, okay? And this is a curve where we improve the temperature in function of the pressure. And high temperature and high pressure make a more efficient system. Of course, the pressure take energy, but anyway, we have advantage. And important, this is a very important point. We are operating at 150 up to 300 Celsius degree, between 10 up to 250 bar. Okay, this is a curve where I represented the temperature in function of the pressure. But very important, this one. If we consider the electrical efficiency, we are now at 200, in the case we are operating at 250 Celsius degree and 37 bar, you can see the efficiency is 115% in voltage. Why? Because we have a contributor of thermal. It's not a magic number, okay, at this condition. So you can see we can save a lot of money because we expect at the end of the program to save more or less 35% of electricity. Okay? Thank you.
Thank you. Last on our list here, unless we have Robert Müller, ich glaube he is not here. So last on our list, of course, is Jesper Andersen, Sales Director at Green Hydrogen. Welcome.
Thank you. I'm going to do an elevator pitch here on green hydrogen system. It will be very product oriented on pressurized alkaline, since that's a product we are producing. Green hydrogen system, as you see here, are founded in 2007, so we have been on this green hydrogen journey for quite a long time now. We are placed where everything started from our point of view in Kolding, in the middle of Denmark. We are 310 people today. We were 19 3 years ago, so it's been a very drastic journey we've been on. We have capacity today to produce up to 400 megawatt as a total amount to the market. We have a backlog of around plus 20 megawatt on what we call the A series. I'll get back to that later. We do believe that the commercial momentum is on all of us that have pitched today. We're just a part of this big puzzle of decarbonizing what we are going into right now. Also, I have to mention that we are on the Nasdaq in Copenhagen. We went IPO in 2021, which of course was the accelerator of where we are today as a supplier. As a supplier, we have tried to simplify the product we are delivering to the market. So basically, we have two products. We deviate a bit from other suppliers. We do see both small electrolyzers have 1 megawatt as something we have to support on the mobility on power-to-power sites across Europe. And then we see a huge market for the megawatt or eventually gigawatt. We are not there yet, but we have developed what we call the Accelera. It's a 6 megawatt module. Another item where we are a bit different from other is that we don't build a process plan to our customer. We have fat-tested module that you can place in modularity concept exactly to the amount of kilograms that your site is needing. The two different components you see here, there are different spec to those. The biggest, what we see as the advantage is that we have increased the output pressure, which is extremely important when you're trying to make a good business case and remove some of the capex that is placed in the equipment coming after the electrolyzer. I would also mention that the X series is not a fata morgana. We have built and delivered the first 6 megawatts to the first site in Denmark, the Green High Scale project. It's under installation right now, and it will be commissioned quite soon. This is just the first step up to a 100 megawatt under this Green High Scale funded project. So for us, it's extremely important. The journey we are on, to keep focus on time here, is that it is a prototype. We have to acknowledge that with all the impact that will have. But we, as it's written here in Q1, we're doing the first prototype. End of 23, we would start to accelerate the sale, write commercial agreement. And in end of 24, we will deliver the first commercial X-Series to the market. As a final slide here, I would say that the two different products, it's important that it's a modularity concept to the market. We do fulfill the guarantee the market needs to make project bankable, because we know that we need to make it bankable if it has to be sufficient, and you or we need to create the momentum. That was all for me. Thank you, and see you, or you're welcome at booth C31 if there's any questions.
Thank you. We've reached the end of the presentations, and I'm hoping that we can get a few more microphones up here from the back of the room. We're going to begin our discussion now, and the whole point, I don't know, can you pan the camera out so that we can cover the whole stage? Is that possible? I'm not sure if I'm off camera. Okay, all right, because I may wander over there. Could I ask you all gentlemen who've presented here today to join me on the stage for this discussion? And this is where I get nervous, because this is the big real estate at the fair. These guys are worth more than a lot of our... It used to be when we started here, of course, the pen manufacturers, they would be doing, you know, half a dozen to a dozen units. See if you can... oh, this is really cozy, isn't it? I knew this was going to happen. Things have changed. So I started this conversation with how we have to transition to net zero. There's so many ways of talking about this technology. I want to begin with a few complaints. One of the complaints is, and by the way, when I say complaint, of course, this industry is the key to transitioning to net zero. On the other hand, I think about the communication. Whenever I hear the efficiency question, I get frustrated, because people will talk about the efficiency of solar panels. It's only 50%. Do we care? It's the price per kilowatt hour, stupid, right? When I hear, and this is a complaint, by the way, I've done this with your colleagues, please bear with me. When people talk about the price of per kilogram, do you guys know what a kilogram of hydrogen is worth, what you can do with it? There used to be people who could transition to, they would simply say, okay, so what that means is if you got a kilogram of hydrogen in your car, you can drive this far. And they could even tell you about the models and so on and so forth. Or they could say, okay, the price per kilogram translates to what price of electrical energy? That is, let's make this understandable. Of course, part of the problem behind this math is that some of these people have a direct consumer anyway. If you're working towards decarbonizing the industry, you may have an industrial consumer who already buys per kilogram units of hydrogen. Do we have a communication issue here? is this even realistic? And I think we should start with the people who do smaller scale stuff, because the smaller scale stuff is really, you're trying to create an electrical grid, for example, that just doesn't exist. They haven't serviced this neck of the woods before. And this could be, by the way, we're not only talking about Africa. Have you ever seen the brownouts and blackouts in the United States? So maybe you could address that, Manuel, to start the conversation. Translating what you do in terms of dimes and cents for the consumer.
Do you hear me? Oh, yeah, now yes. So sure, very interesting point. I think that small electrolyzer, big electrolyzer, it doesn't matter. All here, we are here for a reason. We want to promote a hydrogen society. To do that, we should move. We should provide the technologies. We should provide the technologies for consumers. We should make people aware of hydrogen and make people touch hydrogen, know what is it. They often fear it. That is true. They believe hydrogen is dangerous. They don't believe hydrogen is the way towards a new society. Instead, here we are all convinced that we need hydrogen in our future. What to do? Everyone here showed technologies, very interesting technologies, and game-changing technologies with electrolytes to produce hydrogen. We discussed efficiency, we discussed price. Those are nice questions. But the point is, society now is not ready yet. We don't find hydrogen in our lifetime. Do you see hydrogen at home, at work? We don't. We should. And for small-scale electrolyzer, we have a mission. We have to bring hydrogen to people. How can we do that with megawatts? We have not decided to do it. We will leave the other guys here do it, but we can convince people touching hydrogen. You know, boats, for example, small boats with hydrogen. You know, no smoke when you move with your boat at leisure, or at home, residential applications. We had other examples of residential applications here, so maybe we can discuss them more. But we believe that people should get in touch with hydrogen. And it is really hard with megawatts, because not all companies dealing with hydrogen have that amount of money, that amount of people to target that. We are a small company in BluEnergy in Italy. We are developing our experience in some years. We know about hydrogen, and we want to bring it to people. That's the mission. We should do that before talking about, price of hydrogen and price of technology. At least that's my opinion. I don't know what you others think about it.
You want to add? Yeah.
Yeah, of course, I would like to add. Thanks, Manuel, for bringing up this topic, and Brian as well, because we see ourselves as some pieces of this huge puzzle of energy. And we need all system types that you've heard today. We need huge systems, we need medium-sized systems, and we need a lot of small systems to combine many possibilities, because we've got millions of small sites of energy, diesel gensets powering, for example, mobile phone antennas or small villages or whatever, remote locations, millions of those. And as long as we don't supply those with clean, green energy, we will not be successful with the energy transition. And this simply can't be done by multi-megawatt scale huge systems, because the logistics of the energy aren't simply possible to bring to all the islands, to all those remote places. And that's where we come into place as a piece of a puzzle, where we point out bringing in very quickly small systems that can start now and not in 5 ages, when 20, 50, 100 megawatts are available. That, for example, is one advantage of our smaller systems, where we can provide energy to the people now.
Of course, go ahead.
Yeah, actually, I think most of the manufacturers of the electrolyzers started their first pilot plants from baby-sized. We also do the same. So we find a solution for our customers. For example, in China, we have many industrial consumers. They're using cylinders of hydrogen for their welding, for their tungsten, for their furnace. But it's very difficult for them to keep the 150 bar cylinders in their small shop. So what we can provide them, that we provide them with a baby-sized online hydrogen generator. That will help them to find a solution. They can push the button and have the hydrogen coming out. So when we're talking about the size, let's first think about what our customer need. What we can provide for our customers.
Yes, if I can complement what has been explained, I think really what matters is the cost of delivered hydrogen at the point of use. at the pressure you need, at the purity you need, in the quantity you need. And efficiency is one of the parameters actually in that equation. And your question about efficiency is also it depends on the cost of electricity. If electricity is expensive, efficiency will matter. If electricity is for free, you can afford to have, I would say, a lower efficiency, and then you will focus on the capex. But at the end, you need also to consider all the transport of the hydrogen from the point of production to the point of use. And so I think that's a total equation that needs to be considered, but the TCO actually of the hydrogen is what matters for our customers.
You just use the word efficiency again. It's a word I love and I also hate because it's very difficult to know. Of course, efficiency is important. When wind turbines are turned off, you have a loss of CapEx. Is that efficient? No. If you can use that excess energy, then you have this equation of you have electrolyzers, they produce hydrogen, they are used for grid stabilization, but again, we have the CapEx equation. You want your electrolyzers to run 24/7. Wouldn't you prefer that? Not simply intermittently, but literally for long durations. So all of these things play into this issue of efficiency. It is always complicated, isn't it?
Yes, clearly. So I think, say, most of the systems are designed to operate under like flexible operations. But obviously, if you look at the business case, the more you operate your electrolyzer, the better is your cost of hydrogen because of the capex amortization, obviously. From the case that you mentioned about like using curtailed wind energy to make hydrogen, that's a business case we don't see a lot right now, because the number of hours of operation is too small, actually, to generate this type of interesting business case. So what people are looking for is high utilization rates of those electrolyzers, and then combining wind with solar, and also dedicated renewable production for cheap hydrogen production.
Yeah, Ulf?
Yeah, thanks. I want to bring up some thoughts about efficiency in general, because since more than 100 years, all of us accept that we drill oil somewhere deep in the ocean, bring it via pipelines or ships to a refinery, waste energy by refining, by transporting it again to the refueling stations, bringing it into our cars and trucks and whatever else, and burn the oil that has taken a lot of energy to bring it to your car, burn it with 30 to 40% efficiency at all. Sorry, what are we talking about? Hydrogen electrolyzers is at a stage of maybe 65% roughly in general overall efficiency, and you can do everything with hydrogen. Green, without pollution, without CO2 and whatever else. So never ever talk about efficiency, please, because it's completely untrue that we ever had in a more efficient way of storing energy and transporting it.
Yeah. Okay. I just wanted to add one point here. We'll have to get back to this notion that hydrogen is a very flexible gas. You can do a lot with it. You can create e-fuels. Is it a good idea? That remains to be debated, but largely burning hydrogen is not the best way to use it. You still, though, can use excess production of energy, create hydrogen, and put it back into the gas grid. The guys at NEL, you got to tell the story, basically. Back in 1928, you had a renewable energy source. You're going to tell the story?
Yeah, that was the first hydropower that was delivering hydrogen for most of Norway, for ammonium, everything it could be used for. So, but efficiency at that time was not important. That was just to get the hydrogen as a clean energy source. But at that time, people was not thinking so much about the CO2 and so on. So it was really difficult to convince the Scandinavian countries to go into water electrolyzers at that time. But we managed to build over 500 megawatt of water electrolyzers in the 1930s, and they were first decommissioned in 1989.
1930 to 1989.
So, yeah.
Yeah, and by the way, you're shaking your head there. Truly so, because we are curtailing renewable energy. They had hydroelectric sources, and you could maximize the revenues of that installation, we're really far behind what we can do. We had an order. Who was next in the line? I think it was you. Yeah,
another argument with efficiency. So you touched an important point. Running the electrolyzer 24 hours a day. You know, most of the times when we touch this point, we find the point that we don't have renewables, or rather, people don't see renewables. They would expect to see them more with their own eyes. So how can they run 24 hours a day? And when we discuss with potential customers and in projects, most of the times people are convinced they need a bigger electrolyzer. Because, we have this peak power, 200 kilowatt peak power, we need that electrolyzer. But that's not really efficient when you run it only a few hours a day. It's much better to run the electrolyzer 24 hours a day, maybe buffering in between. And to do that, you go towards energy packs, batteries. That's what we look forward to, definitely.
Yeah. By the way, we have to choose our efficiency. This is a super important point. What is the capex value of a wind turbine when you have to turn it off all the time because you can't store the energy? It's just like it's a waste of money. Now we know why we have not expanded the potential of renewable energy here in Germany, and that's only like a fraction of what we actually need to decarbonize the industry. Who was next on? I believe it was you.
Yeah, I just want to add some comments. First, I think maybe we are not the right person to answer the question about efficiency, because we have already done very well from the electricity system and electrolyzer. The bottleneck is in the storage and the transportation. In the last tender released in China, a 5 megawatt electrolyzer just cost around 1.2 million US dollar, very cheap now. And we can use the combined system to combine the solar, wind, and the grid to make the electrolyzer work 24 hours. So we have done very well. So blame the people who transport the hydrogen and the stored hydrogen to ask them to reduce the cost. Then everyone can have green hydrogen. And one thing, each year, more than 80,000 tons of hydrogen is consumed, but only less than 2% was green hydrogen. Yeah. So there's a market, there's need. Yeah, just want to add that.
James?
Yeah, thank you. I just adding up to all the gentlemen's point. I fully agree with the point that already mentioned. Regarding efficiency, I think first of all, we are doing the green hydrogen. So as this gentleman mentioned, this is purely zero carbon. So this is bonus one. I think we need to remember this. Why we are here today, we are doing efficiency optimization. We want to use the clean energy more efficient. So I think it's kind of already we are step ahead. We are into the green future, and we want to promote one step more. And another thing is this is kind of like what we have observed in the electric vehicle industry. At first, there's so little volume of the new technology. Definitely, the efficiency, the cost, all that, it looks really bad. But as our humankind, we need to do the need to step up and continue to use the green energy. So I believe as the process goes along, the efficiency problem and also the cost problem will kind of gradually solve in the process. Yeah.
That's right.
Yeah, just also a comment from my side. It's we focus quite a lot on the LCOH with all the impacts we, as an OEM supplier, can trigger. So that is a capex point still. When we want to scale project, we are on a capex cost out curve. We need to reach a lower LCOH price without mentioning any numbers. And in that, LCOH is also a big amount of efficiency. And as from us, we still see that as a huge impact when we want to scale to megawatt sizes. At the same time, we also focus very much about taking the surplus energy that we're getting from an electrolyzer production. You're getting oxygen and you're getting heat. You might as well use to create a better business case. So there's a lot of aspects that we can turn to create a better business case and make those projects viable.
Always is argument about the new energy coming out. Suppose we are only focused on the efficiency, then there's no meaning that why we are combustion the coal into powers, because there's a loss of efficiency. As the gentleman just commented that the green hydrogen, we have oxygen as a byproduct, and also we can utilize the heat for community heating. A lot of extra surprise we can get from green hydrogen. And most important that the whole process, there is no carbon emission.
I can't, we're going to open this to the public shortly, but I can't resist two other questions. One question I think is vital is we have to understand what we're trying to achieve here and what is driving some of this market. And it's very complicated. You people all have business models. This is not the R&D generation, right? You guys are business people. And when I say business, what this means is some of the CEOs are actually business people who have a product that saves money. The materials handling industry, they have bought up in large scale PEM cell-driven forklift trucks because they operate indoors. You don't need 3 of them. You do if you have acid batteries, but you only need 1 because you refill it in 3 minutes. These are like vital solutions. Another thing would be, well, what is the value of a diesel vehicle if you have fine particulate matter pollution in German cities? I, as a citizen of Berlin, can go and complain to the mayor when the levels of fine particulate matter pollution is above a certain level, and he has to shut the traffic down. So all of the logistics have to change. And we even had one manufacturer who commented that 1/3 of the food delivered in one region he was discussing during the pandemic was delivered using hydrogen-propelled vehicles, if you can imagine. So wherever the city density is there, it's also a necessity. But there are other drivers here, and this interests me also large scale. Some of these people, you do volume, and I often wonder, how do you describe the consumer? Everyone here identifies with the easy thing, power at home or a vehicle or delivery vehicles, things that are easily parsed for the consumer. But when you get to the decarbonization of the industry, it gets more complicated, doesn't it? So who's going to answer the question? What are the typical consumers there? You don't need to name names, but do you have any examples? NEL, for instance, you are like gas specialists. You've been there for a long time. When we're talking about hydrogen as an industrial gas, and we've already clarified the issue here, only like about 1% plus a bit right now is green hydrogen. We're still using hydrocarbons. You can take natural gas, run it through a reformer, and you've got pure hydrogen. We need to decarbonize those industries, though, and by the way, Germany, we don't have a supply of natural gas, thanks to... so yeah, what are the typical consumers for the large-scale production?
Yeah, what it is we are seeing, that's definitely in the petrochemical industry for the refineries in Europe, where they are replacing gray hydrogen with green hydrogen. So that's where they are then complying with the Paris Agreement because they are just reducing everything they are doing on the CO2 footprint. We are also seeing a little bit for transport, but not in the same scale as the petrochemical industry. We are seeing a lot of projects coming up with jet fuels, e-fuels, as you mentioned before. And then we have actually sold a couple of projects for forklifts in warehouses also, but for the large scale, that is definitely the petrochemical industry, because they can easily go and comply with the CO2 goals we have here in Europe, just by changing out the gray gas.
And is there a particular take from the Chinese perspective about, you have massive industry, you have a lot of vehicles on the road, one has environmental issues to discuss and so on. Where is the large-scale market for you?
That's really a good question. Because I'm handling hydrogen business, many customers will ask me a question, are you owning a FCV? I say, sorry, I have an EV. I don't have an FCV. The reason is that because we don't have enough facility there in China. We have massive market. The thing is that all the new application in China is driven from the government. So now we have almost every community, we have these EV charging center or something. but we don't have enough facility for the hydrogen refueling. So that's the problem. But another way that the residents has to change their mind on the driving the FCV, which they consider that is dangerous. We have many businesses in South Korea, and then I first time found that in Korea they have many Hyundai Nexo automobiles running on the way. So because Korea the government is promoting very much about that. So that's my idea about that.
Maybe just one point adding up to you. So except for the family used cars, I think the commercial used cars in China, they are using more and more fuel cell vehicles. Because this is easier for the government to push. And actually, in last year, what I mentioned, the 2022 Winter Olympics, there was a huge exhibition project that around 500 vehicles were powered by the fuel cell for along the whole Olympic game. Yeah, I think it's in the process, but it could be a long process. Yeah.
Maybe just add on what James said. In China, there's a province called Inner Mongolia. There are a lot of mining trucks. So actually, this is a rich province, but a problem of the CO2 emission. So the government invests a lot in the fuel cell trucks. This province is also rich of solar and the wind resources. So that is actually the best practice to use renewable power to generate electricity, to use the electricity to produce hydrogen and then fill the trucks. So there are a lot of projects in Mongolia. So if you have interest, you can just Google. Yeah, you will get a lot of information.
Probably, if I may, I think your original question was about the applications for hydrogen, correct? Yep. And so I think the end goal is full decarbonization by 2050. And that's why we are all here, because we need to decarbonize. And so there are three main sectors. There is the power sector, the mobility sector, and the industry sector. And all those sectors, they will actually have hydrogen. So indeed, refinery is certainly one of the key drivers. There's also the fertilizer industry, which is one of the first customers today for hydrogen made from natural gas. So those are the big existing customers. Then you get a lot of industrial users, but also what we see is new markets for hydrogen, like green steel. And those applications that did not exist before, but they offer a way to decarbonization. And there are many applications, like in the pulp and paper industry, in the glass manufacturing, etc. We see a lot of new applications coming. So obviously, this is really like the sector of growth for our industries, but also mobility. Actually, everyone has mentioned what car is driving. I have the pleasure to drive a hydrogen car. It works extremely well. So the technology is there. It just needs to be deployed. And what we will see is that also on some of the power application, we might see a role for hydrogen there. So power generation, probably beginning with backup power type of systems. But when there will be hydrogen pipelines, we are going to see gas power plants that will burn hydrogen to produce power when there will be no wind and no sun. And so actually most of the gas power plants which are being built right now in Europe, they will be hydrogen compatible. And so this will be another use for those applications.
And for sure, centralized application of hydrogen, we need them to push a hydrogen society. But what about decentralized applications? We look forward of having decentralized application, to have the possibility to have hydrogen locally. To do what? To store energy. You know, electrons, they are not the best to be stored. Of course, we have batteries. We will always have batteries. Thanks God we have them. But storing all energy in batteries in a decentralized approach, that's not our future. We will have many different points where we need to store energy, and hydrogen is the perfect vector for that. So we will need also localized production. We will need both approaches. We will need a centralized production of hydrogen to use for our society, and a decentralized one with smaller applications to store energy.
I almost wish one of the colleagues at Plug Power was great at telling us about whether it's possible actually to convert all cars to electric. Is there enough copper? And certainly, with a certain volume, you have to restructure the whole grid. So this decentralized grid concept also applies to electrification of the vehicles. I want to open this up right now, but basically the dramatic aspect of this conversation, we started years ago with like 7 people, and now we fill the stage twice. And the amount of area covered by electrolysis in this fair is at a maximum. They're the big, that's the real estate out there. So it's phenomenal what has happened. And yet still, we heard the number, only 1% roughly of hydrogen that is consumed by the industry is green hydrogen. When we talk about creating a renewable electrical grid, we're talking about 15% of the energy consumed in Germany. The other 85% is fossil fuels. And if you look at how that's consumed, 1/3 of that is domestic heating. Everyone in their apartments have their own Gasetagenheizung in Germany, so they all basically have their supply of gas. We need to retool a lot, but fundamentally, what this means is we have to get from not only 1% to 100% renewable hydrogen, but we also have to cover the energy needs that is now serviced by fossil fuels. This scale is almost beyond comprehension. It really is massive, and I always say, everyone is happy to have a business model. I think it was you who said, I even have a backlog. Ladies and gentlemen, all these people will have a massive backlog. How do you keep up with this? And my question is very simple, and this is, I promise, my last question. How will you keep up with the goal? 2050 is not that far away. And really what has to happen is such a dramatic increase of harvesting renewable energy, making hydrogen a commodity that is traded internationally by ship, importing it to countries that don't have renewable energies in large quantities, distribution of hydrogen, but above all, electrolysis, electrolysis, electrolysis. Is it feasible? Do we have the materials that we need to create all these electrolyzers? Does anyone have a visionary answer to that question?
Only one comment. We have to keep in mind one thing. This industrial revolution is a must. We have to do it. The previous industrial revolution, we wanted to do it for best technology. Now it's different. We are in a position where we must act. So we are not running for business. We need to do this to save the planet for the next generations. That's what we have to keep in mind. So we should invest into that. We should not gather things, but we should invest into that. We are forced to do it. We have to do it.
Do we have any questions from the audience? We do.
PEM-based electrolysis has many advantages over similar technology. However, a bottleneck of depending on certain critical raw materials. So I wonder, the leading industries presenting today, do you have a business model which will include circularity to ensure your market supply and development future?
Okay, I can take it. They are looking at me, so I can take that difficult question. Yes, so clearly that's a point of attention for PEM technologies, but also on the fuel cell side. So I think the whole industry is looking at first ways to reduce the amount of those rare materials in the technology. On our side, we have already reduced by a factor 10 and the use of rare materials in our PEM electrolyzer technology, and we are aiming at reducing it again by a factor 10. Obviously, we're also looking at other technologies. We don't have a mono technology type of approach. We are working on both alkaline and PEM, but also on solid oxide technologies and anion exchange membrane technologies. And I think we'll need them all if we want to achieve the huge target that you were describing. We'll need all those technologies. And for some applications, we expect that we will see some technologies dominating. Like if you think about offshore hydrogen production, probably PEM is more suited for those applications. If you are looking at applications with high temperatures, probably solid oxide will be dominating. If you are looking at large systems where space is not a constraint, probably alkaline will be dominating. And so we need all those technologies, and I'm pretty sure all my colleagues here would agree with that statement.
Mm-hmm. One of our colleagues here, Mario, you mentioned CapEx reduction, of course, as one of the important factors in your manufacturing model here. Is your CapEx reduction related to the quantities of precious metals that go into your units, or is the CapEx reduction achievable somehow else? Is that a fundamental?
Hello? Yeah. So our scope is to help the company that want to produce an electrolyzer, offering our experience in pressure and temperature in order to reducing the cost of energy. This is absolutely mandatory to do. Frankly speaking, if we are talking about SOEC, high temperature electrolyzer, it's a little bit complicated to make more popular. But if we are looking for high temperature in the range 200, 350 degrees, this is a normal temperature is vented by steam from industrial. It's a vest. And we can use vest. Just to give you one example. I asked at the agency, Italian agency, to have a look at what is the market for this kind of solution. And they back to me and say, I'm living in Milano, in Italy. And the distance between Milan to Venice is 300, more or less 300 kilometers. We have more than 1,000 opportunity business, because we have more than 1,000 industries can use this way to power by thermal steam the system in order to reducing the need of electricity. In this case, the efficiency go up a lot. What I show is tested in university, of course, in the small scale, but now our target is to make more large. And this is, for me, is a very, very core of the problem. Reducing the cost, because in Europe especially, we have a very high cost in energy. We have the same project in India. In India, we have order for Indian company to design 5 and 20 megawatt stack alkaline, traditional alkaline. In this case, it's not important the cost of energy, because the cost of energy is nothing. But if we rest in Europe or America, if you want, it's very, very important. And if we are able to save 30% of the energy cost, I'm very, very happy to say, oh, babe, oh, guy, now we can produce at not €2 per kilo, but less. Also in Europe, because we have a problem in Europe. If you go in Australia, it's not a problem. If you go in Chile, it's not a problem, because still now they are producing at €1 per kilo. Okay, but in Europe we have this problem.
Any other questions from the audience? Anything to add from the stage here? No? I would like to thank my guests. By the way, refreshments for you people, for your participation, are going to be served now, so we get to drink a beer together. I want to thank the audience for their patience, and also for the people on stage. This has been another one of those engagements. We used to argue. We used to have great debates about, what's better, alkaline or PEM. People would get all excited and so on and so forth. And now I think the business model is so far. I mean, you guys have things to do. And there's room for variations there. And there's a lot of cooperation among the largest people on the fair, the people with the large business models and the glowing future. We have to get there. Without electrolysis, we won't arrive. Thank you very much for your participation. So, off to the drinks.